This heating curve explains when you heat up a substance, which type of changes will occur in a material. For example, you have this ice, and this ice is at minus 20 degrees C. When you heat up this ice, temperature of this ice will increase, and then it will turn into water at a specific temperature, and that specific temperature is 0 degrees C, and this 0 degrees C is its melting point. And yesterday I told you when melting occurs, temperature remains constant until all the solid turns into liquid state. Yes, Sansha, this Friday we have a test. And when you heat up this water, water will turn into steam. And this is boiling. And at 100 degrees C, your water will start to turn into steam, and it will remain constant until all the water is turned into gaseous form. So this is known as melting point, and this one is boiling point. Now, this is a change in temperature when you heat up a material. This is it. First, on x-axis, there is energy or time of heating. This is energy, or you can also write time of heating. And on y-axis, there is temperature. So starting point is minus 20. And then this is 0. And this is a point which is 100. When you heat up, temperature of this ice will increase. And when temperature comes at 0 degrees C, it will be constant. This is a temperature. Oh, sorry. So when you heat up, temperature will increase, and it will come at 0 degrees C. And then for some time, this temperature will be constant. This is a constant temperature. Again, it will increase and comes at 100 degrees C. And then again, it will be constant for some time, and then again rise. This is the heating curve. When very first time temperature is constant, this is melting point. This 0 degrees C is a melting point. And when the second time temperature is constant, this is your boiling point. And these are the different points in the heating curve. This is A. Here we have B. This is C. And then we have D. And next is E. And the last one is F. These are the different points on the heating curve. At point A, there is solid. At point A, your state of matter is solid. And at point B, when the very first time temperature is constant, at this point, melting starts. At point B, melting starts when the very first time temperature is constant. And at point C, when the temperature starts to increase, at this point, melting ends. And at point D, when the second time temperature is constant, at this temperature, at point D, boiling starts. And then again, when temperature starts to increase, at that point, boiling ends. And state of matter at point F is, there is a gas. So at point B, melting starts. Again, I'm going to repeat. At point C, melting ends. And at point D, boiling start. Point E, boiling ends. And F is, this is a gas. So this is your heating curve. Now, what's happening at micro level on these three states? Now, you can see between A and B, temperature is increasing. Between A and B, if temperature is increasing, it indicates increase in kinetic energy. Yesterday, I told you if temperature is increasing, it means kinetic energy is increasing. So this much amount of energy is used between A and B. I'm writing KE. KE is increasing between A and B because temperature is increasing. Now, between B and C, temperature is constant. If temperature is constant between B and C, it indicates kinetic energy is also constant. Now, here this question is raised why, where this amount of energy is being used, because this amount of energy is not used up to increase the kinetic energy, and where this amount of energy is going on between B and C, when the melting starts and melting ends between B and C, this force of energy is used up to reduce the forces of attraction. This energy is used to reduce between B and C to reduce the forces of attraction between the particles. To reduce the forces of attraction between the particles. So this is the reason B and C temperature is constant. Now again, B between C and D, what's happening? Between C and D, again, kinetic energy is increasing. Between C and D, kinetic energy is increasing because temperature is also increasing. And between D and E, again, temperature is constant. When the temperature is constant, but energy is still absorbed, so this amount of energy was used up to reduce the force of attraction. To reduce the forces of attraction between the particles. And again, between E and F, kinetic energy is increasing. So this is your heating curve. Again, I was explaining. Hello, can you hear me?
Yes, sir.
Sorry, there was a problem, internet connectivity issue on my side. Can you see my screen?
Yes, sir.
Now, again, I'm going to recap. So this is when the temperature is constant between B and C, temperature is or energy is used between to reduce the forces of attraction. Between B and C, forces of attractions are being reduced. So this is the reason temperature is constant. Between A and B, temperature is rising. It indicates kinetic energy of the particles is increasing. If kinetic energy is increasing, what will happen with the movement of the particles? If kinetic energy is increasing, it indicates movement of particle will also increase. Particles will also increase. This is the reason why temperature is increasing between A and B and why temperature is constant between B and C. And next part is between C and D. Again, this C and D temperature is increasing. This C, if temperature increase, it indicates increase in kinetic energy. So between C and D, temperature is increasing. It indicates kinetic energy is increasing. And between D and E, temperature is constant. If temperature is constant, where this amount of energy is being used up? Between D and E, forces of attractions between the particles are reduced. Attraction between the particles reduced. So these things must be on your fingertips when you are going to solve the paper or solve the questions. When temperature increase, it indicates kinetic energy is increasing. When the temperature is constant, it indicates forces of attractions are being reduced. When kinetic energy increase, it indicates movement of particle will also increase. So kinetic energy and movement, they have direct relation. If kinetic energy increase, movement of the particles will increase. If kinetic energy is constant, it means kinetic force or amount of energy or movement will remain constant. Now, what should be the state at point A? This is point A. At point A, state is a solid. And B is at point B, melting starts. Again, I'm repeating, at point C, melting ends. And at point D, boiling starts. And point E, boiling ends. And at point E and F, again, kinetic energy is increasing. Now here, I have a question. What should be the state of matter between B and C? This is a point which is G. What should be the state at point G? At point B, melting starts, and point C, melting ends. So between B and C, there will be solid plus liquid. And Zunuran, yes, you're right. At point G, we use a specific term to explain the solid and liquid. We call it semi-solid. Semi-solid means half is solid and half is liquid. Both the things, they are present. Semi-solid means half is solid and half is liquid. And between C and D, there will be a liquid because temperature is increasing, and between C and D, this is going to be liquid. Can you tell me the state at between D and E? Between D and E, there is semi-gas. Between D and E, there is semi-gas. There is no semi-liquid. So this is going to be semi-gas. Semi-gas means half is a gas and half is a liquid. This is the heating curve for this substance. Now, can you draw the heating curve for sublime material? Now, there are two times state is changing. Number one was ice. Ice is turning into water. Water is turning into liquid. There are two times state is changing. So temperature will be temperature was constant for two times. That is number one, melting point, and second time temperature was constant at 100 degrees. Whenever a state change occur, your temperature will be constant. So at this point, there are two times state is changing. So two times temperature is constant. In sublimation, how many times state is changing for sublimation? In sublimation, this is any solid material, and upon heating, it directly turns into gas, and this is sublimation. So there is one time state is changing. So when one time temperature state is changing, so temperature will be constant for for one time or for once when you draw the heating curve, and that is, this is your heating curve. On x-axis there is energy, or y-axis is temperature. And when you heat up, temperature will increase, and for once temperature will be constant. When very first time temperature is constant, its sublimation starts. At point B, sublimation starts. At point C, sublimation ends, and this is D. This A is a solid. B is sublimation starts. At point C, sublimation ends, and at point D, there is a gas. So there will be one time temperature constant when sublimation occurs. Yes, Zuluren will move towards after this heating curve will move towards cooling curve. Yes, in the cooling curve we'll switch the graph. No, 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 ऐसा नहीं. No, this is 100% temperature and energy because energy is independent value. So independent value that is on x-axis and dependent value is on y-axis. So temperature is dependent on energy. So this graph or axis cannot be switched. So this is your heating curve for sublime material, and this when the temperature is constant, this is sublimation point. Now I'm going to give you different materials. You have to draw the heating curve and you have to label the heating curve as well. You have to label the point in which temperature is in, kinetic energy is increasing and forces of attractions are reduced. Draw the heating curve for substance X. Its melting point is 60 degrees C and boiling point is 190 degrees C. Draw the heating curve and properly label this heating curve. And this is why its melting point is 400 degrees C and boiling point is 1300 degrees C. You don't need to follow the proper graph. Just you have to show us just a sketch where temperatures are constant. Very first time when temperature is constant, it indicates melting point. When the second time temperature is constant, that is boiling point. Vadika, they don't they cannot switch the axis because it's understood x-axis, there will be a independent value and dependent value, which is temperature, that is on y-axis. Now, draw the heating curve for this x and then y. And draw the heating curve for this substance Z. Z is a sublime material. And sublimation point for this Z is point Z is 113 degrees C. This is a sublimation point. Draw the heating curve for these three substances X, Y, and Z and properly label these heating curves. I'm giving you 5 minutes for these. You have to label each and everything. Number one is temperature. When temperature is rising, kinetic energy is increasing. When temperature is constant, it indicates forces of attractions are being reduced. You have to label properly. Pick your answers for X, Y, and Z. This is your heating curve for X. Very first time temperature is constant, it indicates melting point. Second time temperature constant, it indicates boiling point. And then boiling is over. This is melting point, which is 60 degrees C. And for boiling point, this is 190 degrees C. What's happening between these 2 points? This is A and B. Between A and B, kinetic energy is increasing because temperature is increasing. Just I'm writing short form, kinetic energy is increasing. And between B and C, temperature is constant. So if temperature is constant, it indicates forces of attractions are being reduced. This amount of energy was used up to reduce the forces of attraction between B and C. And again, between C and D, temperature is increasing. If temperature is increasing, it indicates kinetic energy is also increasing. And D and E, temperature is constant, which indicates forces of attractions are reduced, and E and F, there is kinetic energy is increasing. And at point B, melting starts. And point C, melting ends. And at point D, boiling starts. And at point E, boiling ends. and F is a gas. Between B and C, what's the state? Between B and C, this is going to be semi-solid, and between D and E, this is going to be semi-gas. In a similar way, you will draw the heating curve for substance Y. This is a heating curve. When the very first time temperature constant, your graph will be like this. And this is temperature is constant. Again, it will increase. And this is a heating curve. The very first time, this is melting point, which is 400. And for boiling point, which is 1300 degrees C. Again, between these 2 points, A and B, B melting starts, C melting ends. At point D, boiling start, point E, boiling ends, and F is our gas. Between A and B, temperature is increasing, which indicates increase in kinetic energy. And between B and C, forces of attractions are reduced. And between C and D, again, this is kinetic energy is increasing. And D and E, forces of attractions are reduced. And E and F, again, kinetic energy is increasing. So this was about heating curve for normal substances, for substances which go from solid to liquid. And from liquid, they go into gas. So this is your heating curve. You'll explain in this way. And for this is a for sublime material. There's one time temperature is constant. This Z, which is in a solid state, when you heat up this Z, it will turn directly into a gas. So there is only one time state is changing. So when there is one time state change, your temperature will be constant for once. This is a heating curve for substance. Z, this is a sublimation point. This is a sublimation point. Sublimation point for Z is 113 degrees C. This is A, and point B, sublimation starts. Point C, sublimation ends, and point D, there is a gas. Between B and C, both solid and gases are present. Both solid and gases, they are present. Between A and B, temperature is increasing. Again, it indicates kinetic energy is increasing between the solid particles. And between B and C, forces of attraction, energy is used to reduce the forces of attraction. And between C and D, kinetic energy is increasing. This is your heating curve. Any question related to this heating curve? I hope everyone got the point of this heating curve. Now let's move towards cooling curve. Thank you, Vedika. Now cooling curve, this is opposite to the heating curve. Normally, heating curve explains when you go from solid to liquid, liquid into gas. This is a heating curve. All these changes, these are explained by heating curve. So very first change that occur, that is melting. And that second change is boiling. But when you cool down a gas, gas is turned into liquid and liquid turned into solid. So in cooling curve, these states you will learn and will study. Gas is converting into liquid and liquid into solid. These things are explained by cooling curve. So in cooling curve, you will cool down a gas, temperature of this gas will decrease and loss of energy will occur. Your gas will turn into liquid, and conversion of a gas back into liquid, this is known as condensation. And this is opposite to the boiling. Condensation and boiling, they occur at same temperature, but condensation occur upon cooling and boiling occur upon heating. And next point is step will come, that is freezing or solidification. Freezing or solidification. So in the cooling curve, temperature will start from the top. This is our cooling curve. All the reverse process will occur in cooling curve. When you cool down a gas, temperature of that gas, particular gas will decrease. And very first time when temperature is constant, it indicates condensation starts. And then again, it starts to decrease. That is the indication condensation is over. All the gaseous particles, they turn into liquid state. And then again, temperature will decrease after its crossing its melting point. So very first point, this is melting. Sorry, this is boiling. When you move from, this is a point A, this is B, this is C, and D, this is going to E, and the last point is F. At point A, your material is a gas. B is at point B, this is your condensation point, condensation start. Gases, vapors, they starts to condense. And at point C, condensation ends. All the liquid is, all the gaseous particles or gaseous vapors, they turn into liquid state. At point C, after C, there is point D. At point D, freezing starts. And at point E, freezing ends. And at point F, there is a solid. So we started from A, which was gas, and ends at solid, which is point F. So when the very first time temperature is constant, it shows boiling point, or you can also show, you can say this is condensation point. Condensation point or boiling point. And when the second time temperature is constant, it shows freezing point or melting point. This is melting point or freezing point, because both the temperature, they are same. This is freezing point. So between A and B, what's happening? Between A and B, kinetic energy is decreasing because temperature is decreasing. Kinetic energy is decreasing between A and B. And between B and C, what should be the state? For B and C, it's going to be semi-gas. For semi-gas, half is a gas and half is liquid. Both the things, they are present between B and C. And between between C and D, state of matter is, it's a liquid. There's no state change, but kinetic energy is decreasing between C and D. And again, between D and E, temperature is constant. It shows kinetic energy is also constant, but forces of attraction are being reduced between D and E. And again, E and F, temperature is decreasing, so which indicates kinetic energy is, these are the forces of attraction are developed, sorry, between D and E when temperature is constant. So forces of attractions are being developed between the gases, between the liquids particle. And B and C, when the temperature is B and C semi-gas, so between B and C, forces of attractions are increasing. Between B and C, forces of attraction are increasing. Again, between D and E, forces of attractions are increasing. Opposite process occur. So this was change in state. And about cooling curve. So between C and D, there is liquid. And between E and F, there is solid. And A and B, this is a gas. These are the states of matter and cooling curve and change in energy, kinetic energy and forces of attraction. D. Everybody got this point? Forces of attraction and cooling curve. Hassan Shah, are you here? Okay, now this was a cooling curve for normal substance, cooling curve for sublime material. For example, this is iodine, and sublimation point of iodine is 113 degrees C. And you are cooling these iodine vapors from 150 degrees C. When you cool down this iodine, temperature of this iodine will decrease. So which shows decrease in kinetic energy, and again temperature is constant, and again temperature will decrease. So very first time when temperature is constant, it indicates when the very first time temperature is constant, it indicates sublimation point, and at point A there is gas, and at point B sublimation starts, point C sublimation ends or deposition end, and at point D there is a solid. At point C sublimation or deposition or desublimation ends, and at point B deposition or desublimation starts, and at point A there is a gas. So between B and C, both solid and gases are present. Solid and gases, they are present. And between A and B, there is a gas. And between C and D, state of matter is solid. So this was about cooling curve for these sublime material. Now I'm going to give you different materials. You have to draw their cooling curve and their change in energy and forces of attraction. Very first point, this is substance A. Its melting point is 20 degrees C, and boiling point is 190 degrees C, and for B is melting point is 40 degrees C, and boiling point is 500 degrees C, and for C this is sublimation point is 88 degrees C. Sublimation point is 88 degrees C. Draw the cooling curve for these substances and label those cooling curve.